Hello, my name is Edgar Lopez, and I'm going to present my paper, Multi-Agent Based Simulation of Financial Transactions for Anti-Money Laundering. I come from here, from Blekinge, and my co-author is Stefan Axelsson. Um, Criminals use money laundering to make the proceeds from their illegal activities look legal in the eye of the rest of the society, and we don't really like this. So what we have done is we studied these difficulties of applying machine learning techniques to detect money laundering. We analyzed the pros and cons of using a synthetic data set for this domain. We addressed the problems of and advantages inherent to the generation of this data set, and we present an approach based on multi-agent based simulation. And for all of this, we use a case study based on a mobile money service. I will start with a little bit of background on what money laundering is. Everybody knows money laundering affects the finance of the nations and contributes to an increase in the funding of criminal activities. Uh, current methods for detecting these anomalies are pretty basic. They are based on established fixed thresholds, and these thresholds unfortunately are set by law, and they don't make any distinction between different economic sectors or individuals. And of course, this leads to fraudsters to change their behavior in order to avoid these controls. As you can see here, about 2 to 5% of the global GDP is being laundered. It's quite a lot of money. And detecting this behavior is quite expensive. Just in Sweden, it's around 400 million kronas. Here we have an scheme of how a typical money laundering cycle works. First, we have in this part over here the collection of the dirty money. So they do the first part of the cycle, that is the placement. So they inject the money into a bank, and initially the bank, well, they must have some problems, like had you heard about the case of HSBC that had a lot of problems in controlling the injection of money. And once the money is here, they go abroad. They just do a second stage that is called layering. And in this part, the money goes from bank to bank, trying to erase the the way the money first came into the financial system. And finally, the integration. Here we can see purchase of luxury assets, but in the worst case, it can be also used to finance criminal activities. So what we can say is that it's difficult for the authorities to detect money laundering and prosecute the fraudsters. Uh, the high amount of transactions and the variety of the tricks that the fraudsters had makes this task very complicated. And the criminals are now taking advantage of the globalization of the world economy. So they transfer money very, very fast across international borders. And that's what makes this problem interesting for us to study. So I will start explaining a little bit about our case study, that is the mobile money. As I say, this unfortunately we cannot disclose the real name of the company we're working with. Hopefully in the future we will. Company AB developed this mobile money service, and this service provides the ability for the clients to transfer money very, very simple between different customers. And the task that we had at hand is to provide a tool that detects suspicious money laundering activities. The mobile money service, unfortunately, is not running in a real world situation. It's been developed, but still, this leads us to the problem that real world data is not available in this moment. So it means that we cannot use any representative data to train the machine learning algorithms. So we're interested in using machine learning because several of these techniques have been using for fraud detection and specifically for money laundering. And we're interested in using machine learning because we think that we can improve the performance in terms of high true positives and low false positives. over other classification models that are based in just thresholds. So one of the difficulties, as I say, that we have with this domain is the lack of available datasets. So the approach that we propose is to generate a synthetic dataset, but this leads us to think, what are the implications of using machine learning techniques for money laundering detection in a dataset consistent of synthetic financial transactions? Well, this is still an open question. So in order to answer these questions, we have been going through the benefits of using synthetic data. So among the benefits, we have that we can generate as much data as needed to represent the scenarios that we need. The privacy of the customer is not impacted at all. The disclosure of the results is not affected by any policy or legal issues. The data set that we have is available for other researchers to validate the experiments. And as I said before, different scenarios can be modeled with parameters controlled by the researcher. And we also have we can control the injection of enough and normal data to address the class unbalance problem in machine learning. And we can also, through the simulation, simulate the normal behavior, and we can prevent the problem of mislabeled classes. Still, this doesn't come for free, so there are also some disadvantages of using synthetic data, and among them is that the data can have a bias. It can be not representative enough to classify to build a good classifier. It's also difficult to build a realistic model due to the complexity of the variables and parameters that we had to handle in the simulation. And it is still unknown if we can transfer the learning from a simulated dataset to a real dataset. So I will start explaining our approach that is multi-agent based simulation. So this involves the use of autonomous and interactive agents, and it's been used previously to model complex systems. We believe that we can obtain a model based on multi-agents that will be realistic enough for the purpose of analyzing possible scenarios and build a detector for money laundering. So a little bit of introduction. Mobile money resembles a social network where the clients over here are connected to other clients. So this represents the links, and each client represents a node in the graph. So here we can have a scenario where 200 different accounts are distributed across 7 different cities, and they produce legal transactions. We can also have a second scenario here where we isolate all the generation of suspicious transaction. So in order to make these agents to work, we had to define a behavior, and the behavior that we define for our agent is the agent can do either a deposit, a withdrawal, or a transfer. And the agent needs to be a little bit of autonomous of choose what to do. So one of the variables that we use for him to select the type of operations that it's gonna do is the balance. So let's say the balance can affect. If the balance is too low, maybe deposit is more likely to happen than a withdrawal. And if the client has also some clients and has some balance, so maybe a transfer can also happen. And client B is affected by the original client by injecting some money in the balance, and this will change, of course, the behavior of the client being the next step of the simulation. And we also have some transition to the states. So we have different profiles inside the system. So a client can pass from one profile to profile 2 with a specific probability, and the account can also be declared inactive. There is also a probability for this to happen. So here I present a little bit about the architecture of our solution. So everything is centered about the client here, that is our agent. Inheriting from this client, we can generate the behavior of the fraudsters, and we can also specify different kind of simulations that can be combined to generate the transactions here. That this is the final outcome of our simulation. So we produce a file that can be used for injecting the experience into the machine learning algorithms. So specifically, the scenario we simulated, we create 200 clients from 4 different cities. Around 10% of the clients behave as malicious agents. All the fraudsters were connected in a network where the 3 previous roles of money laundering chain were represented: the injection, layering, and integration. The idea behind is that a higher proportion of fraudsters, we try to prevent the class imbalance problem. And the simulation was run 5 times for 1,000 steps, and the results were combined at the end. So the outcome of the simulation is, as I said before, it's a log file that contains transactions, and we generated 486,000 in total, and 6,000 of them were flagged as suspicious. Here I have a little bit of example of how the clients behave. So we have, for instance, in red, one agent that is behaving as a malicious agent. So you can notice that they go pretty close to the threshold, that is 35,000 kronas. And some other clients behaving normally. You can see here immediately the different patterns. As an output, we use these transactions to train machine learning algorithms. We train different algorithms just to test them, and we found quite interesting results in random forest, JRIP, and JGraph. So we went a little bit further here, and we found that JRIP produces quite simple rules that can be applied, and some of them are obvious, but some of them are not that obvious, and can be maybe applied for trying to classify initially the risk of a client when they come to the bank. And random forest and JGraph, they also produce interesting results, but the tree generated by random forest is a little bit too complicated for an operator to understand it. As a conclusions, we have that finding anomalies within this domain it represents a challenge. We say that a synthetic dataset can simulate different scenarios that are not available for experimentations and analysis. We also say that there is always a risk of generating a dataset that is not realistic enough for the real world. So we propose multi-agent based simulation as a good approach to obtain a realistic simulation for this domain. Future work, we're now focusing on building a bootstrapping model for this simulation, which will be based on a real mobile money transactions. And we also like to test other algorithms such as support vector machine, neural networks, link analysis, and some Bayesian networks. That's it, and thank you all for your attention.